Good afternoon. I'm Wilfred with SJB Group, and I have the pleasure of presenting a topic at this year's JESC convention on subsurface utility engineering. I'm going to talk about recent developments and upcoming changes. But before I do, I want to call attention to the items in the bottom. I'm going to pretend as if you're a live audience, and I would ask you what those are. And you would scratch your head, and if you named them, I would give you a bag of what those things are. So what are they? They are, they are divining rods, witching rods, dowsers. The process is called doodle bugging, water witching, water finding, water dowsing. There are people that will swear it works for finding underground water. So some people will also swear that it is useful for finding utility lines. Science says that is not so, but we'll talk about it again later. So here we are. All right, so a good SUE person, finding utilities is like a detective finding a criminal. So this TV series, Detective, played this song as its theme. I hope you can hear this. We had a so a hint is this series started in 1958. I knew the theme song, but I probably wasn't watching it because it was I was what, 6 years old at the time. Anyway, this is theme song from Peter Gunn. He was Mr. Cool. Again, so good afternoon. I'm Wilfred Berry. I'm a partner with SJB Group. The company made an investment in subsurface utility engineering in 2014. We purchased a used air hydro excavation truck, and along with the tools, we've since changed out that truck to the newer model that you see on the bottom right. We have multiple electromagnetic radio detection systems that we use for pipe tracing. We have rodders that are detectable. We push them up in pipes, tone them, and find where those pipes are. We have stick and push cameras that can examine sewer lines and sewer laterals, drainage lines to make sure they're straight and true and not damaged. We also have rotary concrete coring tools so that when we have to penetrate pavement for a Class A test hole, we core the concrete and then we repair it, and then we put the coupon back in the hole. It's almost as if it never happened. And so in our business, we are active with DOTD, Move BR, industry, some local industry around Baton Rouge, and local developers. All right, so today we're going to have a quick review of subsurface utility engineering, and we will just talk about why SUE was created, what are SUE services, using the deliverables correctly, benefits of SUE services, and then what's coming down the pipe when the new standard 3820 comes out. So underground utilities, they're everywhere, right? And so in the picture on the right, the larger one, that's Boston in the early 1920s. They're busy uncovering the street to make some sort of repair or improvement. And look at that bowl of spaghetti, it's amazing. And then Baton Rouge, not Baton Rouge, I mean Bourbon Street in New Orleans. I was at a convention at the Astor Crown Plaza, and this New Orleans was almost just as bad. This picture doesn't show, I couldn't find the picture that really showed it at its worst, but they're rebuilding the streets in New Orleans, and this happened to be uncovered while I was there. So there are over 50 million miles of underground utilities in the US. They're all installed at various depths, made of different materials. They have various sizes, and they have different ways to access them. More being installed daily at greater depths, less detectable materials. And so you can imagine, again, all the pipes and cables that are everywhere. So no one entity is in control with a variety of laws everywhere, policies and attitudes. So what's the design problem? Well, as engineers and architects and contractors, we all want to know what's underground before we start working. And for us to plan anything as engineers, we have to have underground utility location data that's reliable. Well, this has been a problem. Years ago, before there was plastic materials, it wasn't so hard to find pipe as it is today. Well, but with the proliferation of plastics, non-metallic pipes, it's really a problem today. So prior to SUE being officially recognized as a practice, the way you did it was you called one call, 811. While that's a valuable tool during the construction phase, one call was never meant a design tool, and therefore the level of accuracy is uncertain. In fact, they really don't want to come out and locate for engineers or surveyors. But anyway, one call locators have up to 100 tickets a day to clear, as much as that, and they are not aware of the other utilities. They're usually in the area for just one utility location. So fixing the problem. There is a need to utilize new technologies to find and map underground utilities. The designers and contractors have to be able to understand the accuracy of the utility information that we're giving them. And then there's a person or firm in this process that needs to be held accountable for the locations that are being shown. So, subsurface utility engineering, it's a process that combines civil engineering, surveying, and geophysics. SUE is an engineering service performed by a licensed engineer that informs the client of the quality of the utility information they are receiving. And all of this is based on the standard of care that is promoted by the publication ASCE 38. And that publication is used to judge the quality of what we're showing. ASCE 3802, what is it? Well, it was created by the American Society of Civil Engineers in 2002 with extensive discussions, committees, ballots, very involved, the development of that policy. It's 18 pages. It defines terms that denote the quality of utility information and their depiction. Every successive quality level provides more and more detailed utility information. And so what are these levels? These are like grades on a test. A is good, D is not so good. But in the case of SUE, D is what we usually start with. The quality level D is a compiled map that records the best information we can get from utility owners, their records, their verbal discussion about where certain facilities are. We get all that together and we map it. That's quality level D. C is the next step up, where we take that map and we go in the field and we find all the elements that we can see visually, and then we map them with surveying, with GPS. And then if we can intelligently connect the dots, we're going to do that with good engineering judgment. So after that, if there's a greater need for accuracy, there is level B. Level B is taking the appropriate technology, tracing the utilities out, finding what we can on the surface, marking those locations, and again, we survey all those dots. Now, these are a whole lot more dots, and presumably we only put paint down on pipe that runs laterally along the road, not road, but we're connecting dots close enough to where it's obvious that the lines go, that we can connect the dots. And then level A is that when there are issues, conflicts, clashes between existing utilities and what may be designed and constructed in the immediate vicinity or in its place, level A is, or a test hole is done to locate it in 3D space. And we also, at the time of test holes, we identify the pipe, the owner, the material size, and the depth, and the XY location as well. So quality level D, there's an example of a map that shows existing utilities. It's a compilation of all the utility records and owners that are available at this particular location. And its accuracy is solely dependent on what is given to the SUE service provider. And again, these records can be drastically different. This particular one, it's a parcel map, and it's got some references to where things are located. It's got some ties to pavement, etc. This is a nice one. It can get a lot more vague than this particular example. So quality level C is taking that map, looking for the surface evidence of the utilities that we just looked at, and mapping them in with total stations or GPS. This particular piece is a scanner. So we correlate that data in the field to the utility records, and it's an improvement of what quality level D was. But still, there may be some situations where we just can't connect the dots unless we do a level B, and that's what level B is for. So quality level B is inclusive of C, and it uses a variety of geophysical methods to determine the approximate horizontal position. These tools are radio detection and electromagnetic, which are used for pipe and cable locators. And then there's ground penetrating radar. We have magnetic locators that are good for finding iron. And then we have acoustic locators that are good for following sound that is induced by us or by an SUE service provider. And then there are sonde devices, which is sort of an electronic tip of a rod, gets pushed into pipe, and the sonde puts out a radio signal, and then you use a radio detector to track the sonde's travel. That particular device is not as active as it used to be. So all of this should be reproducible, repeatable, might be a better word, in successive investigations, so that we're finding the object as indicated on the plans easily and repeatably. So pipe and cable locators, there's several different kinds, slight differences in technologies, but they're good. They really are good. They are the tool of choice when starting out trying to find underground pipe and cable. So there's a wide range of frequencies. Why is there frequency differences? Some ground, some soil types, some pipe sizes, some depths all respond better at different frequencies. So this is good at locating metallic utilities or those installed with a metallic tracer wire. The cons, if it's not metallic, you really can't use it. And its accuracy depends on available connection method. And what that's saying is you got to be able to touch the pipe to really connect and bond to it to induce a signal on it. Other utilities in proximity can impact because you can get bleed over some of the signals. It can bleed over to other utilities. The next thing you know, you might have two utilities of the same signal that you're marking instead of just one. So you got to be careful, and that's when you would change frequencies when that happens. All right, ground penetrating radar. Looks like a push mower. It's got four wheels. It's got a radar generator, and it's got a sensor. So the radar waves go down, strike the object we're looking for, and then it's reflected to the sensor on the ground. Again, there are different devices with different frequencies. The one we had that you see in the picture on the right actually has two different frequencies operating simultaneously, and they are good for different depths, very helpful. One frequency is good for near surface objects, and the other one is better at more deeper objects. You can estimate the depth, but generally it's not that great for depth. So Gpr suitability is highly influenced by the type of soil and the presence of moisture or water. This is a map that indicates the suitability of Gpr in Louisiana. As you can see, dark green is very high. That's going to be an alluvial soil that is not alluvial soil. It's going to be a sandy, loamy soil and dry, and that is your ideal soil. You're going to see in the Florida parishes on the right, there's light green, but the moderate, the lighter yellow is pretty much everywhere in Louisiana. And the brown, the very low, is going to be your alluvial soils that have clay and a high water table. That's not good. The purple is offshore, more or less. It's going to be coastal, high, very wet, and not suitable. All right, pros. Can be used to locate non-metallic utilities. And we need that, right? Because the radio detection we can't use on water pipe, plastic water pipe, such as PVC and concrete pipe. There's a little chance of interference due to the proximity of other utilities. Doesn't bleed over. It's a reflection. The cons, it's highly dependent on soil conditions and groundwater, and it's highly dependent upon utility depth and size. The bigger objects we see better. The smaller ones, it may be difficult to image. The depth again poses a problem. Anyway, the technology is sophisticated, and the interpretation of the data requires a lot of training to interpret correctly. Acoustic locators is a relatively new tool in the toolbox, and you put noise in water, and you listen, and you can trace out pipe. Obviously, you have to have a liquid medium, but for water pipes, this works reasonably well. And the way it works is that you connect to a spigot or a fire hydrant, you turn the water on, you have to have a little bit of water moving, and then there is a valve that goes on and off. It kind of puts a chatter sound in the water medium, and then you can trace with radio phones and that acoustic device he has on the ground there, you can trace that out. And what he's doing, what this example shows, is that the intensity of the noise, you go left to right and it dies off. That's, you know, one end of the spectrum. You go to the other side, the other end of the spectrum, and then you're going to paint where the sound is the highest. And the farther you go away, you'll still get that spectrum, but then it does get fainter. At some point, you have to go to a new source of water and put the sound generator on it. So pros and cons: good for locating non-metallic utilities such as PVC and concrete pipes. Soil conditions are not as impactful. The cons is that you have to have a ground connection. And then if you have anything else going on around you, if you got any, I don't know, stuff like a dozer that's moving the ground, anything that's inducing vibrations into the ground is going to have a problem. And of course, if you have a lot of noise around you as well, it's just going to affect your ability to listen to the headphones. Magnetic locators are exactly that, looking for objects that are magnetic in nature, and that's ferrous, metallic pipes and valves. And so some steel can be found, and some steel is not going to be found. But generally, you're going to find cast iron pipes, cast iron valve boxes, cast iron valves, that sort of thing. And it's good. It's used to locate ferrous materials. Cons is that it's highly dependent upon utility depth and size, and you're not going to get any kind of information about how deep that item is. So this is really more for finding objects that are just under the ground. Surveyors use them a lot for finding property corners, the rods. So quality level B, we use the whole toolbox with numerous types of different sensors and locators to gain a confidence in utility locations. And so depending upon the type of utility and the project location, certain pieces of equipment are more successful than others. And so we have to use good engineering judgment on which tools to use. But if we're not finding them, we're going to exhaust the toolbox. That's the thing. We're going to use the one that really gives the best indication. So what's the difference between quality level B and one call? Well, one call, it's just that. It's to help someone that has a property owner or a contractor that is going to make improvements to a certain area. You call one call, tell them what you're going to do, and they're going to notify all of the utility owners that they have records as having utilities in that area. So when a ticket, when a one call locator goes out, he usually represents only one utility. It's rare that utilities will use the same one call locator. Usually gas systems use their own locate personnel, staff, and then other utilities will farm it out and hire these locators. So quality level B, a service provider at quality level B possesses or at least has requested all available utility owners' records, versus the one call locator. He's only got records for that one owner that they're under contract with. A supervisor is going to find all the utilities capable of being found. The one call is only going to mark what utility he can find that he is supposed to find. He's not going to look for abandoned or unknown lines. Our supervisor has many pieces of equipment. He's out there by himself with a small truck, and he probably has maybe 2 pipe locators, cable locators in his toolbox. So supervisors map a larger area, allowing better familiarization with utilities on site, because remember, we're tracing on and off the project site to make sure we connect dots in the right way. The one call locator is usually only going to look in one area and may or may not connect enough dots to say what's really going on. Supervisor has a realistic time frame, but the one call locator, he's got a lot of things to do all in one day. He's under severe time constraints. Okay, so let's talk about the dig law. Louisiana Dig Law, in its Article 1749.14, it talks about the tolerance zone. It defines the tolerance zone as an area not wider than the width of the underground utility plus 18 inches on each side. So here in the graphic, we have a duct bank that's 24 inches wide. You add 18 inches on each side. That's 36 plus 24. That's 50 inches wide that he has to take care of how he disturbs that ground. So the red flag says somebody went and located this facility. The red flag, that red flag could be off as much as 50 inches in sort of in either direction. And so that's why we have this tolerance zone as wide as it is. So if he's excavating, a contractor, he has to hand dig that 50-inch width until he identifies the pipe, at which then he can make good construction contractor judgment about how to excavate further. Tolerance zones. So excavators should observe a tolerance zone when digging close to a service line, any kind of pipe or cable. The width of the tolerance zone is specified by law. I just talked to you, it's the width of the utility plus 18 inches on each side, and here you have a 12-inch water line plus 18 plus 18. So that tolerance zone is 48 inches. So the red note says any excavation within the tolerance zone should be performed with non-powered hand tools or a non-invasive method until the marked facility is exposed. All right, so one call versus sue. This is an example in real life. So one call marked a duct bank about 5 feet wide. And if you look in the photograph, that duct bank is signified by the red stripe, red diamond, red stripe, red diamond, red stripe, etc. That's about 5 feet wide. When in reality, when the SUE provider was done, there was only a single cable there. That's not to say 811 one call locators are not good. No, it's just sometimes they get it wrong, and the SUE provider is there to make sure. So quality level A is inclusive of all of the other previous levels, commonly referred to as a test hole or a series of test holes. And it generates a very precise horizontal and vertical location. And as part of that effort, we're duty bound to note the type of material, the size of the utility, what's it made of, the depth, the condition, and obviously where it is located in 3D space. Currently, the ASCE 3802 requires 15 millimeters for vertical, and I think 30 millimeters for horizontal. That will change in 3820. So here's an example of a 48-inch sewer force main. It's huge. So we're having located, so we have a dry erase board. We use it over and over again as we mark this line or any line going down the road. As you can see on the left, it's test hole number 3, cut depth, owner, type, sewer force main, 48-inch, ductile iron, and it's black. And it probably has a vinyl wrap around it to protect it from acidic soils. Barnett Road, job number, and then it's a phase that we charge time to. You notice all the metadata that's recorded in these photographs, which I think is pretty interesting. What day the picture, the time, East Baton Rouge Parish, there's some other information on there. Then in the middle, you see the metadata of which way the camera was oriented. So going that way is, I guess, northwest, top of the picture. And then on the right, we're going to put a level rod in there. We put the level bar, my words escaping me. We just make sure that the top of ground, when we take the top of ground measurement all the way to the level rod, that is level, so we get an accurate reading on that level rod. All right, SUE deliverables. What do we typically provide? You're going to get a CAD file, either MicroStation or AutoCAD, depicting the utility information. And then we're also going to give a hard copy or PDF. We'll put Google Earth in the background showing where it was on the Earth. And then we're going to give a SU report providing additional information that normally is not included in the drawings. That SU report is very useful, and it will be required or in 3820, which is coming. It recommended in 3820. All right, so electronic files, we know what these look like. Water lines, gravity mains of some type. This is the hard copy drawing. That's Google Earth imagery behind. The blue water line is W, and the B is there to say that we located that line using quality level B. It looks like everything on here was quality level B. And we're also putting the owner's name, sizes in the material. Now this is B. With A, you're going to see something a little bit different. So this is the test hole data form that you're going to get in a QLA observation. I can blow this up a little bit. So you have name of the project, client, owner, utility type, and then you have location information, depth, the width, the diameter of the pipe, steel material, color black. There's also there's northing and eastings, and we may have state plane coordinates on here, but I don't know that I see that. All right, so there's the vicinity map showing where it is. That's the project limits. Notice that we're locating outside the project limits to maintain a sound, strong opinion about what direction it was going when it got outside the project limits. So we have a legend, we have test hole profile, we're given information about the typical values, where those values are taken, the numbers that are written above in this form. Of course, we're stamping it. And that's a typical data sheet. So the SUE report, it's a signed and sealed technical report. It supplements utility drawings and really contains information that you otherwise might not put on the plans, it might not get conveyed to the client or the user. And it assists the end user in understanding the subsurface utility landscape and its associated risks. This is going to be required with 3820 when that comes out. All right, what are the benefits of SUE? Well, it allows you to design around existing utilities with a whole lot better faith about what's going to happen and what you can do and can't do. It reduces change orders during construction. That's dramatic that it does that, and it minimizes unknowns. These are all related together. The cost savings have been studied by numerous universities and institutions. For every dollar you invest in SUE, you avoid $5 in spending delays and damages. It does, it's an environmental protection action. We minimize disruption to pipelines, water loss, pipelines getting broken, oil releases, etc. And it avoids mistakes. Again, these are all interrelated. So for the contractor, it's all about safety. There is a huge effort right now. I see it in LinkedIn. I see it in advertisements. I see it in our profession. 811, you see the little logo on the top right, know what's below, call before you dig. There is a huge communication campaign about the dangers of digging without calling 811. Again, to the contractor during construction, it saves money for them when they know where everything is, and therefore they can avoid busting them. Lots of stories about contractors working in schools only to break lines and send the kids home. Parents don't like it. Nobody likes it. All right. So how do how do you manage risk? What happens to the risk? So without SUE, pretty much all the risk and whatever's going to happen on a design and construction project is that the professional and the owner are going to take on all that risk. Whereas if you have a SUE engineer and you eliminate a lot of those unknowns, there's a whole lot less risk on the part of the designer, and because the SUE engineer is going to take that on. All right, so what's next? 3802 is going to become 3820. It's going to happen this year, we think, and I'll talk a little bit about that. So these are the two different titles. On the right, you see the new title. It's the standard guideline for investigating and documenting existing utilities. It's a little different. So the head of the committee that's rewriting 3820 is Jim Onspach, and he is recognized as the founder of SU, the process that we use today, and to continually improve the process. We'll talk about those changes. All right, so what's the same? We have the same, essentially the same definitions. They've added some terms to the definitions. They're still the same quality levels, A, B, C, and D. They're using a lot of the same deliverables and attributes, standard attributes. The engineer and project owner tasks are pretty much the same. They have value studies, they moved to the appendix, and they have additional geophysical methods, and it remained in the appendix as well. All right, so what's different? They have specific performance goals that are a little bit more descriptive in how things, what things get done and how they get them done. Another big change is the inclusion of area utilities in definition and deliverables. I'll talk a little bit about that later, and that's significant. They have some new and revised definition, but not much. The survey accuracies for QLC, B, and A have changed, and they've loosened it a little bit. Then there's the commentary. So they're going to include vaults and other structures underground that are voids or thrust blocks. When we know about them, they were going to ask that we locate them. That really wasn't addressed at all in 3802. And there's some new geophysical methods. They talk more about depths in 3D models. They introduce that concept. 3D BIM is in GIS is going to come. We are going to organically populate some sort of model. If it's not BIM, it'll be a GIS with everything that we find, so that we can, over time, improve the depository of what we know about where things are underground. And then there's a utility report. We're doing the utility report. It's really a good technique to describe the reliability in general of all the activities that were performed. All right, so the performance goals, they are trying to determine how a project is designed to have minimal utility issues during the project development process. And they also talk about how are we going to get protected against utility-related claims during the project development process. These things are talked about and discussed, and it's a better document. So, according to Mr. Onspach, ASCE 38 will be a combination of prescriptive standards and performance standards. As prescriptive standards, it's telling us what we have to do to achieve a particular quality level. And then as a performance standard, it brings in sound professional judgment that should be exercised. So they're really pointing to the professionalism of the service. All right, so knowing this uncertainty allows engineers to make better risk-based decisions regarding placement of design elements, cost, and time to relocate utilities and public safety issues. There may even someday be a discipline that is licensed in suit. They talk about that later on. All right, subsurface utility engineering. The definition has changed over time. In '89, it was just designating, locating, and data management. 2002, they worked, ASCE did it, producing a document that establishes protocols for locating underground assets. It was a committee. They studied it, they worked on it, they published it, and they made sure everything was spelled correct, et cetera, et cetera. And that is 3802. Then in 16, there was a branch of civil engineering that was created, focused on planning, position, design, construction, operation of all utility systems, as well as the interaction between utility infrastructure and other civil infrastructure. So there's now a utility engineering branch. They now have an institute, UESI, utility engineering. I forget what the S is, Institute, but it's a subset of ASCE, and it's dedicated to the science of locating underground utilities. Mr. Anspach is involved in all of those activities. So quality level, pretty much the same definitions. I'm not going to get into the weeds with that because I don't think it serves the purpose of this presentation. They just want good interpretation using standards that are appropriate to the professional. They're saying here, this last one, that it's good for only a specific time. In other words, that it can, as time goes down the road, there may be other stuff placed on the ground. So that's another question that they bring up. How long is an opinion good for? Quality level A, I think it's pretty much the same. All the utility attributes are recorded. The thing that's different here is that I just added in the measurement standards, utility locations for depth in 3802 was 15 millimeters of vertical elevation. That was the standard. You had to be within 15 millimeters. They have relaxed that to 0.1 feet. And according to Mr. Anspach, this was done because it's really hard to establish a height of an object when it's 10 feet down in a hole. You remember I had that little level going across the ground to the level rod. That's sort of vagaries that can alter the accuracy. So they loosened that up a little bit. And then in the horizontal, it's 0.2 feet. Same reason, you got a big object, 48 inches wide. I mean, what's to say the center is exactly, some value. So they relaxed that a little bit too, 0.2 feet or 60 millimeters. So QLA is it conveys the lowest level of relative uncertainty. I mean, it's you do that because you have to know, and it has to be more certain. Quality level B hasn't changed, except with these utility segment was detected through the application of geophysical methods. The signal was judged to be reliable. They're adding this to it. This is, again, professionalism, a call for professionalism in the opinion of where something is. They actually get into the experience and credentials of a locator versus the person, the engineer that's judging where it is and was it located correctly. Again, the project accuracy is 0.2 feet horizontally. And we go through utility level C. They add a new term called a utility anchor point. And it's like a manhole where a line launches from. But the thing now is that you can't assume everything. We'll get into that with vaults. I'll show you what that means or relates to. So quality level D, a value assigned to a utility segment or feature not visible at the ground surface whose estimated position is only through utility records, information from others, or visual clues such as pavement cuts, obvious trenches, or existence of service. Now that's not something about going in the fields. I really think they're pointing to imagery where some of these things are available from a desktop survey of Google Earth or Google Maps, Street View, et cetera, et cetera. Let's see. QLD data is assigned. Says here we can use one column markings, but we have to give it that kind of context when we make note of it in maps. So now there's utility report, utility drawings, put them all together. That's a deliverable. Talks about what's needed in a utility report. So a utility report is going to have a certain amount, a certain dialogue, commentary, and it's an opinion. It's going to be signed by the professional, provided to the project owner, the client, paper form, or a 3D model, and/or a 3D model. And it's going to have the description of the project, the contract requirements, what the supervisor was, commissioned to do, the metadata like those pictures I talked about, when everything about when observations were made, where they were made, and then what methods were used, what cable locator, was it Gpr, a list of all the utility owners, descriptions of information that was used to find utilities, types of equipment selected, types of software, areas swept, non-swept, suspect areas, utilities located and documented by all the attributes. Linear feet designated, did we have problems with it? Was there a conflict with utilities? And then any recommendations for additional work, and that may be dependent on the type of project in the future. Any all pictures, images, that help in the report will be added to the deliverables. So my personal observations, 3820 is going to be more inclusive. If you picked up on the all electric, all cable, all overhead, utilities are going to be included. That's been a sort of an overlapping source of discussion between topographic surveyors and supervisors. Who's doing what? A lot of times surveyors think that, if we can see it, we're going to survey it. And then the supervisors say, if we can't see it, we'll find it. But now this 3820 is saying the subsurface utility engineering should be the provider of choice for locating all utilities above, on the ground, and below the ground. And everything about the overhead should be noted: the meters, the poles, the owners, the voltage, other users on the poles, etc. The other big item they added that really wasn't there before is vaults. Vaults happen in urbanized areas, metropolitan areas. Very common to have multiple large mains entering a vault or a manhole. A lot of electric and cable go in and out of vaults at various points in their routes, and so that's added. So it updates requirements for new additional technologies. It actually loosens some of the accuracies, 0.1 vertical, 0.2 feet horizontal, and I think that's just a realization. That's probably the best we can do at this point in time with our surveying technology. All right, so the big thing is utility report, tying it all together. This is a place where you state opinions, which wouldn't have gotten onto the plans. It enhances definitions, and I think most importantly, it strengthens the professionalism of the standard, and it's going to separate responsibilities and duties of the engineer from the duties of the field locators. You will see certification tracks that will train the locator that will be different from the educational track of the engineer that will manage the process. And then 3820 is going to launch a discussion, and it's going to be about who does what, whether all utility research and mapping should be provided by the topographic surveyor or the service provider. And really, 3820 is going to push the mapping of everything utility related above, on the ground, below the ground, to the supervisor, because really the supervisor, that's who's really responsible, and that's who's really capable and trained of understanding what's going on with utilities in a given area. All right, so Mr. Ansbach says about, when is this thing going to happen? This is his quote he recently gave me. There are a lot of changes coming, but most of the changes are in the form of commentary for interpretive assistance. The standard has passed the committee ballot stage. It's undergoing grammar and permissions editing, and then it'll have a public comment period to follow before publication. I expect those comments to be editorial in nature and not change much of the content. He gave me every reason to believe that this standard would be adopted formally and published in 2021. All right, at this point in time, I would open it up to questions. In hindsight, I should have put a slide where you could email me or call me. The simple email for me is wb@sjbgroup.com, and my cell phone is 225-278-8934. I'm a licensed professional engineer and land surveyor in Louisiana, and I've been practicing, and I'll keep practicing until I get it right. And that's my farewell statement. Thank you very much for tuning in. I hope to meet you in person.